Imagine shouting at someone standing right in front of you and hearing nothing at all. That's what happens on the moon. Sound dies in empty space. But light? Light crosses billions of kilometers of nothingness without any problem. No air, no molecules, no medium. So here's the uncomfortable question. Why can light travel through absolutely nothing, while sound cannot? The answer didn't come from philosophy. It came from watching a tiny moon disappear behind a distant planet. Since the time of Isaac, it has been known that light can have different colors depending on the different frequencies and wavelengths of light. However, if light has the form of a wave, like sound waves, then in order for it to travel from one place to another, it would need a medium. It is known that sound requires substances such as molecules, air, water, or other substances to be able to travel from the source of the sound to our ears so that we can hear it. If we are in space or in a place where there is no atmosphere, no air, no molecules that can transmit sound waves, such as on the moon, even if we are standing face to face and shouting as hard as we can, we will not be able to hear each other's voices directly, but light is the opposite of time. Between the earth and the sun, as well as between the earth and many other flowers, are all separated by the vastness of space. But even so, the light from the sun, as well as from all those stars, can still travel to our eyes and allow us to see it. So the question arises as to why light can travel through a vacuum. Without the need for a replicator at all, the evolution of human knowledge that could lead to the solution of this question began in the late 17th century and began with a Danish astronomer named Ole Romer. During the year 1670, Romeo spent several years in Paris observing and studying the moons of Jupiter. Specifically, it focuses on a solar eclipse on Jupiter, a phenomenon that occurs when Jupiter's moon passes directly in front of the sun, blocking its path and casting a shadow on the surface of Jupiter. In detailed observations and records, Ole Romer focused on an oddity that Italian-born French astronomer Giovanni Cassini had previously observed and recorded. Eclipses on the planet had different intervals. It is known that Jupiter's moons travel around the planet in a regular orbit, so the phenomenon of a solar eclipse occurs when the moon completes a full orbit and comes directly between the sun and Jupiter. It should also occur at regular intervals along the time scale of this orbit. But what the Cassino saw was the complete opposite. According to observations in the month of Taurus, it is seen that the phenomenon of solar eclipse caused by Jupiter's moon, especially the male moon Io, passes directly in front of Jupiter. It happens earlier than in other months, and the difference can be as little as 10 minutes. Through years of observations, combined with data left by the Cassino, Ole Romer noticed that eclipses on Jupiter occur more quickly when the planet's orbit is close to Jupiter, and this eclipse is delayed and occurs earlier when the planet's tip moves away from Jupiter towards the other side of the sun. Get out of this Cassino, Ole. Rimbaud concluded that the eclipse on Jupiter was indeed a solar eclipse. It occurs at the same regular intervals without change, but the way it is observed from Earth varies because the distance between Earth and the planet changes. And light takes time to travel through space as Earth approaches the planet. Social crisis image, it will soon come to Earth when the planet is far away. The crisis is increasing at the same time, but we are less likely to see it. Because the distance is greater, light takes longer to travel from the planet to our planet Earth. Of course, it would be many centuries before the speed of light could be calculated with precision, but what Ole did was, or as it was discovered at the time, it was a major starting point for other scholars to gain a better understanding of the nature of light. Another scholar who played a major role in this understanding of light was a Scottish scholar named James. Clerk Maxwell is considered one of the most important scientists in human history, along with Isaac Newton and Albert Einstein. Between 1861 and 1862, Maxwell studied in detail the properties of Michael Faraday. Regarding the relationship between electricity and magnetism, he wrote down a mathematical equation that can prove that magnetism and electricity are not separate forces, but are a single force called the electric magnet. Among the many equations that Maxwell discovered, there was one that described the properties of electromagnetic waves that could travel through the vacuum of space without the need for a medium. But at the same time, Maxwell's equations also revealed another important point that was not previously expected. The speed of electromagnetic waves through space is the same as the speed of light. From this period, Maxwell also drew the conclusion that light not only has the same speed as electric and magnetic fields, but that light itself is actually a relog. Electric-magnetic. Therefore, light can travel through the vacuum of space without the need for any medium. Second, the discovery that light has a finite speed is also a major clue in the evolution of our human knowledge of the universe. It can make us want to look back on the past. As one looks further into space, one can also see further into the past due to the light originating from stars or galaxies, which is far away. It takes a long time to travel to Earth and allow us to see it. However, this ability to see into the past also has its limitations. Some stars or galaxies are so far away that their light does not have enough time to travel to our planet. To date, scientists have determined that our universe was born from the Big Bang approximately 13,800 million years ago. So, any star or galaxy that is 13,800 million light years away from our planet Earth, even if we have a telescope, no matter how strong the force, we cannot see those stars or galaxies because the light from all these stars and galaxies does not have enough time to travel to Earth and allow us to see them. This is the boundary of what is called the observable universe. But this does not mean that our universe is limited to this. Beyond the observable universe, there may also be stars. The galaxy is another side of the galaxy, but we can't see it that much. Examples that make light easy to understand. Let's use some simple pictures, not equations. Example 1. Sound versus light. If I clap my hands, the sound travels through air by pushing molecules. Each molecule bumps the next one, like a line of falling dominoes. Take the air away. No dominoes, no sound. Now imagine light working the same way. If light needed molecules, then space should be dark. The sun would shine brilliantly, but its light would die before reaching Earth. Yet every morning, sunlight still reaches your face. So light clearly isn't using matter to travel. It's doing something else entirely. Example 2. The stadium wave. Think of a wave in a stadium. People stand up and sit down, but they don't move across the stadium. The wave travels, the people don't. Light works in a similar way, except instead of people, it's electric and magnetic fields that oscillate. Nothing is being carried across space. The pattern moves. Example 3. The Jupiter clock. Imagine Jupiter's moon Io as a cosmic clock. It ticks every time it passes behind the planet. If light were instant, every tick would reach Earth at the same time. But they don't. When Earth is farther away, the tick arrives late, not because the clock changed, but because the message had farther to travel. Light behaves like mail, not magic. Distance matters. Example 4. Looking back in time. Now imagine a flashlight turned on 1 light year away. You don't see it turn on for an entire year. When you finally see the light, you are not seeing now. You are seeing the past. Every star in the night sky is a history book written in light. Some pages are millions of years old. Some are billions. Example 5. The speed limit of reality. Here is the strange part. Light doesn't just move fast. It moves at the maximum speed allowed by the universe. Nothing can outrun it. Not matter. Not information. Not cause and effect itself. Light isn't slow because space resists. Light is fast because reality has a speed limit. Transition line. Perfect for ending. And once you understand that, you realize something unsettling and beautiful. The universe isn't showing you what is, it's showing you what was. Because light has a finite speed, the universe has a memory. When we look into space, we are looking into the past. Some stars we see no longer exist. Some galaxies are so far away that their light hasn't reached us yet. That boundary is called the observable universe. Beyond it, there may be far more than we can ever see, not because it isn't there, but because light simply hasn't had enough time to arrive. And that means something profound. Every photon that reaches your eyes is a messenger from the past, carrying the history of the universe straight into your mind.